Out of Ideas Productions presents.
Hello everyone, this is a conjugate multiplication function limit mathematics. As you can see, this is the question. The limit of x approaching 4 is x squared minus 16 over 1 minus the root of x minus 3. I have rewritten the question over here. As you can see, the first step that I did was to factorize the top, which is the denominator, into x plus 4 and x minus 4. And then I rewrite the whole thing into x plus 4 and x minus 4 over 1 minus the square root of x minus 3. And the next step I have written in blue here is to multiply both top and bottom with 1 plus square root of x minus 3 over 1 plus x minus 3, the square root of that. And so the multiplication occurs. The top part, I did not multiply the whole thing, but the bottom, as you have already known in junior high mathematics, a plus b times a minus b equals an a square. So I have written 4 minus x. And then if you observe so close, you can understand that x minus 4 is equal to the negative of 4 minus x. And so I have crossed out the bottom part and this x minus 4 over here as 1 and negative 1. Therefore I have 1 plus the square root of x minus 3 times x plus 4 over negative 1. So the limit of x approaching 4 of 1 plus the square root of x minus 3 times x plus 4 over minus 1 is 1 plus the square root of 1 times 8 over negative 1, which is negative 16. Alright, this is the infinity over infinity type. As you can see, this is the question over here. So the limit of this jumble of numbers over here containing fractions and roots as x approaches infinity is currently this weird number over here. The first step to getting this number is by dividing it by x. That is the highest power, everybody. And so I have this. As you can see, the x here is gone. It's supposed to be an x squared. This is an x. Why? Because the x squared inside here is inside a root. And so the root of an x squared is an x. Thus, the x disappeared. And so this one is regarded as a whole number, 420. Meanwhile, this one, and also this one, is regarded as zeros, as any number divided over as, well, infinity can be regarded as 0. And so we have these numbers over here. We count them, we put the x in, and remember to regard these as zeros. So we have the square root of 420 over 69 plus the square root of 360 over 23. And voila, the weird number.
The problem that we're going to talk about now is the ones that where you need to factorize the function first, because it seems that the problem is when you substitute x equals a to the function, it seems that it gives you a something over 0 where you cannot sort of continue with the process. So you're gonna need to have to factor out x minus a from the function, and really the first step that we're gonna do is to group them by the same power of x's. We can see here x squared minus 4 plus a times x plus 4a over 2 times x minus a. Then really the next step is to just sort of factorize the upper part of the function to x minus 4 times x minus a over 2x minus a, just write the whole thing down again. Then what we can see here is that there appears to be these two, where we can cross them out. They cancel each other, which results to x minus 4 over 2, where in this case we can directly substitute x equals a into the equation, leaving you with the answer of a minus 4. One problem that we're going to talk right now is when you substitute x into the function, it's going to result into an infinity minus infinity sort of type. So we have here the question, the problem limit x of this as x approaches infinity. So really, as you can see, as I have said before, when you directly substitute x equals infinity to the equation, it's just gonna result into an infinity minus infinity, and you sort of cannot continue with the process. So, what we can do here is we can rewrite this into this form, which is basically x minus 2 squared root, which results into this. And by the way, speaking of which, we have a formula for that, for finishing these sorts of problems, which is when you have the limit of these two as x approaches infinity, then there's already a formula which is b minus q over 2 times the square root of a. But one thing to note here is that you need to pay attention that these two are the same. So as we can see here, we have these two. We have the same you call a, and really the next step is to just follow the formula, which is b minus q over 2 times the square root of a, where b here is -2, q here is -4, -2 plus 4 is 2, then divided by 2 times
On
the square
behalf
root
of Out of Ideas Productions,
which results
Samuel
into
and Roy would like to say
solution B,
thank you.
1.